Hello, my name is Andrew Caratu. I'm a teaching assistant at Matopia Academy, and I'm going to be solving all the questions in the 2022 AMC 8. All right, so let's get started. All right, so we have number one. The math team designed a logo shaped like a multiplication symbol shown below on a grid of 1-inch squares. What is the area of this logo? So like we have written in the problem, this is of length 1. And we can see that we can divide the shape up into smaller shapes, right? Like this. We have this square in the center. And the area of the square in the center is, well, 4 square units, right? 2 times 2. And then we add on each of the 12 triangles, each of these little triangles, which have side lengths 1 and 1. So 1 times 1 over 2. That gives us 1/2. So we multiply 1/2 in the equation, and that'll give us a total area of 10. And that's our answer to problem 1. All right. Problem 2. So we need to consider these two operations, A diamond B and A star B. And it's just asking for these numbers in terms of those functions. So what we can do is we can just plug in, right? So 5 diamond shape 3 is just going to be 5 squared minus 3 squared, right? And then we take this in the second function, the star function. So it's going to be this minus the second number, 6. And then we take this and we square it, right? So order of operations, we start with this inside part, and that's going to give us 5 squared minus 3 squared, going to give us 25 minus 9, which is going to give us 16. So 16 minus 6, that's going to give us 10. And then we're looking for 10 squared, which is just going to be 100, which is our answer. All right. Problem 3. So we have 3 positive integers multiplied together such that their product 100. And we have this inequality. So A is less than B is less than C. And we want to find the number of ways the numbers can be chosen. So, well, all the factors of 100 include 1, 2, 4, 5, 10, 20, 25, 50, and 100. All these. So, we know we can't include 100 in the 3 numbers, because if we choose 100 as one of the numbers, the other 2 will have to be 1 and 1, right? But from this inequality, they all have to be different numbers. So 100's knocked off the list. Let's say we choose 50, right? If we choose 50 as one of the numbers, the other 2 numbers will have to be 2 and 1 in order to make the product 100. And from here, we want to organize them from least to greatest. So A would be 1, B would be 2, and C would be 50. That's one of the ways for us to do it. All right. And that's the only way we can use 50, right? So we're done with that. And now what about 25? Well, from 25, there's 2 ways we can complete it, 4 and 1 or 2 and 2. But once again, 2 and 2, those are equal numbers. We can't have any equal numbers. So our only answer would be 1, 4, and 25. So that's the only way we can do it with 25. So now we'll erase 25. So what happens if we include 20? Well, with 20, we can only have 5 and 1 left over. So that would give us the solution 1, 5, 20. And finally, if we use 10 in the problem, well, we can include 1 and 10, or we could include 2 and 5. Once again, though, equal numbers means that this is out. So we only have access to 2, 5, 10. And that's our 4th solution. And that gets rid of 10. And clearly we can't pick 3 numbers here that multiply to 100 without repeating. So for example, if we include 5, right? Well, the only way we could include another 20 would be 5 and 4. But we repeat 2 5s. So there is no way to do it with 5. If we include a 5, we can't do it. And now we're only left with 4, 2, and 1. Yeah, this is clearly not going to multiply to 100 because 4 times 4 times 4, that's 64 only. So it's not going to work. So there's no more solutions. And we're left with these 4. So our answer would just be 4, E. All right, so we have problem 4. So this one's less of an equations or like arithmetic related, and this one's just related to reflections. So we have this letter M, and we're supposed to reflect it over Q and then over P, right? So we should try to visualize that, right? So if it's reflected over the line Q, then it would end up like this, right? That makes sense. And then it's reflected over the line P, which would bring it over to about here, right? So yeah, each point on the M gets reflected to its own corresponding point across the line. So what we end up with in the end is this. And we can look through the answers. It's not A, not B, not C, not D. E matches. So that would be our answer. All right. Number 5, we have Anna and Bella, and they're celebrating their birthdays together. Apparently they're born on the same day. 5 years ago, Bella turned 6 and received a newborn kitten. So Bella's age 5 years ago was 6, and newborn's kitten age 5 years ago would be 0, right? So now, 5 years from then, now Bella should be 11, and the newborn kitten should be 5, right? So the current age of Anna, we can represent with A, right? And if we add these up, 16 plus A is 30. So A is going to be 14. Right? Yeah. All right. So the question's asking, how many years older than Bella is Anna? Well, Anna's 14, Bella's 11. So she's 3 years older. All right. All right, so now we're at problem 6. 3 positive integers are equally spaced on a number line. So we have our 3 numbers, right? We have like 1, 2, 3. The middle number is 15, and the largest number is 4 times the smallest number. Well, if they're equally spaced, then this distance, if we call it, let's say, M, this distance must also be M, right? Because they're equally spaced, which basically means this number is 15 plus M, and this number is 15 minus M. So if we set things up, the largest number, 15 plus M, is going to be 4 times the smallest number, which is 15 minus M. So if we expand this, we get 15 plus M is equal to 60 minus 4M. And what we get is 45 equal to 5M. M is going to be equal to 9. So our 3 numbers are going to be 6, 15, and 24. So the smallest of the 3 numbers is going to be 6, which is C. All right. Problem 7. The World Wide Web first became popular in the 1990s, and download speeds were a maximum of about 56 kilobits per second. So how many minutes would the download of a 4.2 megabyte song have taken at that speed? Well, first we need to convert it to kilobits, which means we take this 4.2 megabytes and multiply it by 8,000 to get the number of kilobits. And then we need to divide this. How many kilobits in the 1990s can we download in a minute? Well, that's pretty simple. Since we can download 56 in a second, we can download 56 times 60 in a minute. So this is the amount we need to download. This is the amount we can download in 1 minute. So if we divide these two, we should get the amount of minutes it'll take. So we can eliminate some stuff. Like, for example, make this a 42 and then remove a 0 from here and a 0 from here. right? So basically we removed 2 zeros from this number, one to make this a 42 and the other to make this a 6. And then we can cancel these in order to get 6 times 80 over 8 times 6. And then these cancel and these make 10. So it'll take 10 minutes. There we go. All right, this one looks complicated because we have to multiply a total of, seems like 20 fractions. 20 fractions, that's a lot of fractions. How will we ever multiply them all? But remember, when we have a fraction, right? Like just any old fraction, like 9/12, we take something out of the numerator, we take something out of the numerator, we take something out of the denominator, cancel them, right? And that reminds us of this problem because, well, this total fraction will be equal to 1 times 2 times 3 times 4 times 5, all the way up to 20, right? But what we can do is, instead of just writing the numbers 3 times 4 times 5 up to 22, what we can do is we can shift them over slightly like this. And now you see what's going on here, because this is a common factor, this is a common factor, this is a common factor. All these numbers cancel until we're just left with 1 times 2 over 21 times 22, and this will just simplify to 1 over 21 times 11, which will just give us 1 over 231. So yeah, everything cancels basically. All right, number 9. A cup of boiling water is placed to cool in a room whose temperature remains constant at 68. Suppose the difference between the water temperature and the room temperature is halved every 5 minutes. Okay, so let's take the difference, 212 minus 68. It's going to give us 144. So we're going to take this difference, and after 5 minutes, it's going to halve to 72. After 10 minutes, it's going to halve again to 36. And after 15, it's going to halve again to just 18. So then we can take the 68 room temperature and add back on that 18 in order to get the new temperature, which will give us 86 B. All right. All right. So this next question, problem 10. We have Ling, who decides to take a hike in the mountains. She left her house at 8, drove at a constant speed of 45, and arrived at the hiking trail at 10. So we see these various graphs, right? And they all show this journey, right? But they all show different lines. So the question is, which line is actually right? Well, it should start at the point with an x value of 8 a.m. and distance in miles of 0, right? And it seems like all the graphs do that. But the point it ends at should be, well, arrives at 10 a.m. And if she drove at 45 miles an hour and took 2 hours to do that, then she would have gone 90 miles, right? So now we can go through all these graphs and see which ones are actually telling the truth. B is wrong because it shows the distance as only 45. A and E show the right thing. C makes the same mistake as B by going up to only 45. And D makes a different mistake. It goes all the way up to 120. So we're between A and E now. And now she stays for 3 hours hiking. Both graphs show this, 3 hours. And then drives home at a constant speed of 60 miles per hour. Well, we already know took 90, it's 90 miles away. So she would have taken, if she goes 60 miles an hour, she would take 90 over 60, which is equal to 3/2 hours, right? So in this diagram, she takes 2 hours, which is wrong. So A is not the right answer. But in this diagram, choice E, you can see she takes an hour and then she takes another half. So that would be our correct answer. All right, problem 11. We have a donkey who has a very long piece of pasta, takes a number of bites of pasta, each time eating 3 inches of pasta from the middle one. In the end, he has 10 pieces of pasta whose total length is 17. All right, so here's what we can do, right? Here's what we can do. Let's say the original length was n, right? Well, in order to get to 2 pieces, he takes a bite of 3 inches out. So the length would become n minus 3. So 2 pieces that have a total length of n minus 3. Then when he takes another bite, there's going to be 3 pieces, right? Doesn't matter which piece he takes a bite out of, this one or this one, there's going to be 3 pieces. And the bite he takes is going to be 3 inches long, so n minus 6. And you can see where this pattern is going, because when he has 10 pieces, right? He has 10 pieces, he's going to have eaten n minus 27, right? He's going to have eaten 27 inches. So n minus 27 is going to be equal to 17, and we're just going to get n is equal to 44. All right, problem 12. So we have these 2 spinners, and we spin each of them, and let the number n equal 10 times the number on spinner A added to the number on spinner B. Well, this is just saying, like, if we call the number we get here A and the number we get here B, we're just making the 2-digit number AB, right? Like, for example, if we get 6 here and we get 3 here, then we'll get 6 times 10 plus 3. That's just going to give us 63. So all we have to do is just take these 2 numbers and put them together to get our 2-digit number. Well, what kind of 2-digit squares are there? Well, we have 1, we have 4, we have 9, but none of those 3 are 2-digit squares. They start at 16 and go 25, 36, 49, 64, and 81. The next number would be 100, which is too many digits. So we're stuck with these numbers. And also notice spinner B, which represents the last digit of the number, only has the numbers 1 through 4. So this gets rid of 16, 25, 36, and 49. And it only leaves behind these 2 numbers. Luckily, both of these numbers have a first digit between 5 and 8, which is another requirement, right? So both of these numbers can be achieved, right? Like 64 we can achieve by getting a 6 and a 4, and 81 we can achieve by getting an 8 and a 1. Those numbers are on the spinners. So essentially, we have 2 numbers that'll work, and there's a total of 16 2-digit numbers we can get from spinning both of these spinners. So the probability that we end up with one of these 2 squares is going to be 1 out of 8. All right. How many positive integers can fill in the blank? Well, one positive integer is blank more than twice another. Let's call this number n, right? And let's call this one positive integer, let's call this other positive integer x, right? So then this new positive integer would be 2x plus n, right? It would be n more than twice x, right? And the sum of these 2 numbers, well, that would give us 3x plus n, and that would be equal to 28. So the question is, what kind of numbers n would give us the sum of 28? Well, the answer is, well, this has to be a multiple of 3, right? And 28, we can break up into a multiple of 3 plus something else, 27 plus 1, right? Which basically means that n has to have the same remainder when divided by 3 as 1 does, right? So n can be 1, of course, right? Because 1 is 1. And this would make x equal to 9, right? Because 3 times 9, 27, and then add on 1, that's going to give us the same number as 27 plus 1 over here, right? But we can also add 3 to n, and add 3 again, and add 3 again, and continue this until we reach 25, when we have n equals 25, right? Well, what we'd end up with is 3x plus 25 equals 28. So x would just be 1, and our 2 numbers we get are 27 and 1, right? Because 27 is 25 more than twice 1, right? And they add up to 28. But if we try to go 1 number further to 28, the 2 numbers we're going to end up with are 0 and 28. They add up to 28, and 28 is equal to 28 more than twice 0. That still works. But notice it says they have to be positive integers. One positive integer is blank more than twice the other positive integer. Therefore, since 0 isn't a positive integer, this won't work. And any numbers we go on beyond, right? Like if we go to, let's say 31, it's just going to go into the negatives, -1 and 31. And -1 and 29, actually. -1 and 29. And yeah, 29 is 31 more than twice -1, and they add up to 28, but this is negative. And if we keep on going past these numbers, we're just going to get negative and negative more. So since we have to stick to positive integers, we'll cut it off right here. Only count these numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Moving on. So how many ways can the letters in Beekeeper be arranged so that 2 or more E's do not appear together? Well, if we want to keep all the E's from touching each other, right, we have to have gaps in between them, right? And we have to put something in each of these gaps. So we have to have at least one letter in each of these 4 gaps. But we only have 4 other letters to begin with. So you take these 4, put them into these 4 spaces, right? There's no other way to do it. And what we'll end up getting is, well, all the E's have to stay in place. And all we can do is take these 4 slots and shuffle them. So we could write, let's say, E, B, E, R, E, P, E, K, E. That's one example, right? And there's a total of 4 factorial ways to arrange these 4 in these 4 slots. So that would just give us 24. All right. Number 15, we have Laszlo, who went online to shop for black pepper, and he found 30 different black pepper options. That's a lot of black pepper. But in ounces, what is the weight of the pepper that offers the lowest price per ounce? So it seems like at first, oh, we'll have to go through all 30 of these, find the weight, find the price, divide the two, and see like how big it can get, right? So, but in other words, right, like let's say we have a different data point. Let's just call a data point over here, right? And we draw the line from 0, 0 to this point. Well, the price per ounce is just equal to this price over this number of ounces, right? And that's just the slope of the line. So we're just looking for the number. We're looking for the point such that it has the lowest slope with 0, 0, because that'll minimize its price per ounce. So we want to minimize the slope, right? So like, for example, we don't want to pick this point because that's a very high slope, but we might want to pick this point because it has a really low slope. So we can go through all of them and see which one it hits last with a single line. And if you align a ruler, right, if you have a ruler on the actual exam, you can take a ruler, align it with 0, 0, and like slightly angle it down until you see the point that's the lowest, right? So this point right here has the lowest slope, right? Because this point is close to it, but it's not quite the same slope. And this point has a slope really close to it, but it's still slightly bigger. So this is the point with the lowest slope. Therefore, it has the lowest price per ounce. And the weight of this point is going to be 3. All right. 4 numbers are written in a row. The average of the first 2 is 21. The average of the middle 2 is 26. And the average of the last 2 is 30. What is the average of the first and last numbers? So what you could do, right, is just pick any number, right? Like, for example, pick 21. And then the second number would have to be 21 for the average to be 21. Then pick, well, 31, right? Because this would make the average 26. And then the average of the last 2 is 30, 29. And then we're taking the average of these 2. That would just give us 25, right? That's one way to solve it. But to see why this is true, why we always get 25, no matter what number we pick first, we can call these numbers A, B, C, and D. Given from the problem, we have A plus B over 2 is 21, and B plus C over 2 is 26, and C plus D over 2 is 30. And what we can see right away is we take these two fractions and add them, 21 plus 30. That will give us a plus b plus c plus d, all of them over 2. And then if we subtract 26, that's just going to give us a plus d over 2, which is what we want, the average of the first and last numbers. And the sum will end up being 51 minus 26, aka 25. So yeah, that's why the answer is 25. Let's move on. All right. So we have some new notation, right? So we have the normal factorial of a number, right? N factorial, this is just n times n minus 1 times n minus 2, all the way down to 1, right? But this new definition, n double factorial, is the product of all the even integers from 2 to n. And it is only defined for even integers. So n double factorial is going to be, well, n times n minus 2 times n minus 4 times all the way down to 2, right? So we are looking for the units digit of the following sum: 2 double factorial plus 4 double factorial plus 6 double factorial plus all the way up to 2022 double factorial. But if you'll notice, if we go to the number, let's say 10 double factorial, this number has 10 in its product. So it's obviously going to have a units digit of 0. And every number following 10 double factorial will have that 10 in it. So all of those numbers from 10 double factorial on will have a units digit of 0. So they won't contribute to the sum. So therefore, all we need to consider is 2 double factorial plus 4 double factorial plus 6 double factorial plus 8 double factorial, and all the other numbers will end in 0. So we don't worry. 2 double factorial, well, that's clearly just 2. 4 double factorial, that's 4 times 2, 8. 6 double factorial, that's 6 times 4 times 2, which is 48. And 8 double factorial, which is going to be a bit of a big number, but it's not that big of a deal to multiply. And it's going to be this, right? 48 times 8. And we can take a shortcut. Since we're only looking for the units digit, we don't care about this 4. And we can just find the units digit. This is 64, so the units digit is just 4. So it's something followed by 4, but we don't care about this something because all we're looking for is the units digit, which is going to give us 2 plus 8 plus 8 plus 4. It's going to give us 22. So we take the units digit of that. We get 2. Nice problem. Let's move on. All right, we have the midpoints of the 4 sides of a rectangle given, and we're trying to find the area of this rectangle. So these 4 points, let's try plotting them. We'll just sketch it, right? -3, 0. Yeah, let's make that slightly smaller. -3, 0, 2, 0, 5, 4, and 0, 4. Well, we can see these 4 points, right? If we draw this intersects at like a right angle, and we can see that the rectangle that forms these midpoints is clearly going to be a rectangle that looks like this, right? And this is clearly a right angle here because this is 2 and this is 4, and then for these lengths 2 and 4, right? And then for the bigger triangle, if we take this triangle, I mean this with this is going to be 4, and this is going to be 5 and 3, so that's going to add up to 8. So if we see this slope here is going to be 1/2, and this slope here is going to be -2. So since they're negative inverses of each other, it's going to make a perpendicular. So we know that this is going to be a rectangle, and we're trying to find its area. So in order to find its area, what we can do is we can just find this length, which is just going to be this side length, right? Because of parallel lines, and this side length, which this length, the midpoint connected, which is going to be the same length as the side length here. So we'll just take the multiplication of this and this. Well, this, right? We can use the Pythagorean theorem from what we got before, 2 and 4. The square root of 2 squared plus 4 squared is going to give us the square root of 20. And then the other line we're going to get is square root of 4 squared plus 8 squared, which is going to give us a total of the square root of 80. So if we multiply these two together in order to get the area, we'll end up with the square root of 1600. And if we take the square root of this, well, this is just 16 times 100. So we break them up into two, and we get 4 times 10 when we take the square root of each of them, and this will just become 40. C. Right. Number 19. Mr. Ramos gave a test to his class of 20 students. We have this dot plot. Later, Mr. Ramos discovered that there was a scoring error on one of the questions. He regraded the tests, awarding some of the students 5 extra points. So essentially, apparently there was a question on the test that was worth 5 points, right? And some students apparently got it right, but it got scored wrong. So what he did is he regraded it, increasing some of the students' scores by 5. And that increases the median test score to 85. Well, it's saying, what is the minimum number of students who received extra points? All right, well, we should count the number of students, but it already tells us 20. So that's what we know. So basically, in order for the median test score to be 85, we need to have at least 11 points in this range. We need to have at least 11 points in this range. Yeah, because we want the two middle students, right, the 10th and 11th, to both have a score of 85, right? That's one of the ways to do it, actually. The other way to do it is if the 10th and 11th students have scores of 80 and 90, which means we'd want to have we'd only want to have what, 10 students here, and we'd want to have the other 10 over here, right? So we have one over here, and that would make an average. But unfortunately, we can't get 10 students over here because if we can only increase certain students by 5. So if we move all of these two over, it's still only going to make a total of 7 here. So we can't get 10 over here. If we want to try to pull that off, we can't. So that's not a way we can do it. The only way we can do it is if the 10th and 11th students' grades are 85 and 85. So the thing is, we have to get a lot of people to get into this zone. And we can do that by moving students from here, right? So if we move this student, right, that's one student moved. We can move this student up by 5. That's the second student moved. And I should probably like cross these out. Yeah. And if we move this student, that is a third student moved. And now at this point, if we look at the median, right, we're really close because there's a total of 5 points here, 5 points here. That's a total of 10. So the two median points right now would be this point and this point, which would give us, it was almost a median of 85, but not quite. So we're going to have to move one more student. If we move this student, just one more student, we can see now there's enough students here for these two to be counted as the median students. So the average will give us 85. So all it takes is moving a total of 4 students. And we know we can't do this in any fewer because to begin with, there were only a total of 7 students here. And in order to get the average to work, we want the median to be 85. We have to get 11 in this zone. So we had to move at least 4 over, and 4 was enough. So we know the answer is 4. All right. Problem 20, we have a grid of 9 integers. And this is supposed to be like a magic square, right? If you've ever seen a magic square, the sum of the numbers in each row and the sum of the numbers in each column are the same. 4 numbers are missing. The number x in the lower left corner is larger than the other 3 missing numbers. What is the smallest possible value of x? All right, so we want to make a magic square with numbers. We don't know what the numbers are, but we do know that the magic sum is -2 + 9 + 5, which is going to be 12, right? That's the magic sum. So if we take this right here, we know that this, for example, would be 14 minus x in terms of x, because if we add these three up now, we'll get 12. And we can continue this by saying, like, for example, this one would be 4 minus x in order to make the sum 12. And this one would just be 1 plus x in order to make, no, it would be x minus 1 in order to make the sum 12. So yeah, so we have these four numbers, and the number x, so it says it has to be filled with integers. So we know x has to be an integer. And if we make x an integer, the other three will also be integers. So we don't need to worry. But we want the number x to be larger than the other three missing numbers. So it has to be larger than 14 minus x, has to be larger than x minus 1, and it has to be larger than 4 minus x. Well, this inequality will just result in 0 is greater than -1, which is always true. This inequality will always, this one will always result in x greater than 7, right? And this one will result in x greater than 2, right? And we do this by adding on x and then dividing by 2, pretty simple. So from these three combined, right, the minimum value of x we could pick is the minimum where it's greater than 7, because that's the strictest inequality, that's the highest up. So 8 would be our answer. All right. Problem 21. We have Steph, who scored 15 out of 20 baskets in the first half of a game and 10 baskets out of 10 attempts in the second half. Candace took 12 attempts in the first half and 18 attempts in the second. In each half, Steph scored a higher percentage of baskets than Candace, but they ended up with the same overall percentage of baskets scored. So yeah, this is a very simple question, because in order to have the same overall percentage of baskets, right? This percentage here, or fraction, we can just take the fraction. We get 25 out of 30, right? And then for this one, it's over 30 as well. So we know these two numbers here have to add up to 25. So we have x and we have 25 minus x, right? So essentially, we have to have that 10 over 10 is greater than 25 minus x over 18, and that 15 over 20 is greater than x over 12. So if we cross multiply here, or what we can do instead is we can just multiply by 4. So what I mean is multiply by 4. This cancels out to just be 3, and then 3 times 3 gives us 9. So x is less than 9, right? And then from here, what we get is, well, obviously 25 minus x has to be less than 18, right? And from here, we can just get x is greater than 7. So x is less than 9, but greater than 7, and it's an integer. Therefore, we know x is 8. And therefore, in the first half, 8 baskets were scored. In the second, 17 were scored. So how many more did Candace score in the second than the first? Would be 9. So 9C. All right, number 22. A bus takes 2 minutes to drive from one stop to the next and waits 1 minute at each stop to let passengers on board. Zaya takes 5 minutes to walk from one bus stop to the next. As Zaya reaches a bus stop, if the bus is at the previous stop or has already left the previous stop, then she will wait for the bus. Otherwise, she will start walking towards the next stop. Suppose the bus and Zaya start at the same time toward the library with the bus 3 stops behind. After how many minutes will Zaya board the bus? Yeah, so all right, so basically, Zaya takes 5 minutes to walk here, right? So the rules here are Zaya will continue to walk to the library unless the bus is in this zone. Then she'll wait for it. Makes sense, right? So right now the bus is way far behind, so she's not waiting. She's going to go herself. So she takes 5 minutes to walk to over here, right? And then in that time, the bus. So it seems that the bus is starting. Yeah, so it's driving right now. So yeah, so in this time, the bus takes a 2-minute drive to here, right? And then it waits a minute, and then it takes a 2-minute drive to here. So in this next case, right, it's here, it's still waiting, right? So actually what I'll show is I'll like come up with like, I don't know, like notation, like this means that the bus is waiting, and this means that the bus is about to leave, right? So right here, it takes 2 minutes, waits, and then takes 2 minutes. So right here, the bus is here, but it's still waiting for a minute. So now Zaya, well, it's the bus is still over here. So still Zaya is not waiting. Zaya goes on to the next. Now the bus decides to go, well, first it has to wait because it's waiting. So it waits a minute, and then it goes 2, and then it waits a minute, and then it goes for another minute, right? So it's right here. Well, she's over here, and this is where the bus is. So she's still going to go. So she ends up here. And in those 5 minutes, the bus goes here. It waits a minute. It goes for 2 minutes over to here, and then it waits a minute. So now it is here, but it is done waiting already its minute. So now Zaya is going to wait for the bus because the bus is already here. So she waits, and then the bus comes over 2 minutes later. So they meet right as soon as the bus comes here. Well, what's the total amount? Well, the bus drives for 2 minutes, then waits for a minute, then drives for 2 minutes, waits for a minute, drives for 2 minutes, waits for a minute, drives for 2 minutes, waits for a minute, right? 2 1 2 1 2 1 2 1. Drives for 2 minutes, waits for a minute. Now it's over here, and then drives for 2 minutes, and then it finally meets Zaya. So the total number of minutes here we can see is 12 plus 5. If we add those together, we end up with our answer of 17A. All right. Number 23, a triangle or circle is placed in each of the 9 squares of a 3x3 grid. Shown below is a sample configuration with 3 triangles in a line. How many configurations will have 3 triangles in a line and 3 O's in a line? All right, so this question, it doesn't specify whether or not a diagonal counts as a line, but regardless of if it does, if one of the shapes forms a diagonal, then the other will not be able to form any line, right? Like for example, if the triangles form like this, right? The circles, no matter where we place them, we can't form another line, right? We can't form it on the other diagonal because that's an intersection. And any row or column we pick, right, like that or like this, right, it intersects with the triangle. So if we pick a diagonal, we won't be able to place the other one. So we can just assume a line means a row or a column, and diagonals will not work. Well, what we can do is we can just pick 3 circles, right? And just pick how it works, right? And well, another thing about this problem is that it clearly all right. So yeah, actually it doesn't need to be 3 and 6. We can just place any in any of the 9 squares. So for example, we could just place all 9 triangles, but still the diagonal thing still applies, right? Because if we have a single diagonal, right, like let's say with circles, there's no way we can make it 3 in a row with triangles. There's just no way. So therefore, we have to make a row and a column somewhere. So like, let's say we make a row of a column of circles, right? Well, obviously we can't make a row of triangles the other way, then it's going to intersect. So the triangles will also have to do the same thing, right? And then over here, we could just fill up whatever we want, right? Like we could fill up like a triangle, and then like a triangle, and then like a circle, right? So the question is, how many ways can we do this? Well, we can pick where we want the triangles to be. Like we can pick it to be on this, or this, right? Any of those 6. So 6 ways to choose the triangles. And then from there, let's say we pick this one. Well, then from here, we can only pick these two, right? We can only pick two because it has to be the same. It has to be parallel, the other shapes. So let's say we pick this to be the triangles, and then we pick this to be the circles. Then for the last remaining one, we can fill it up with triangles or circles for each of the 3 squares. So that's 8 ways to do it. And that'll give us a total of 96. But that's not actually the correct answer. And the reason for that is that we're actually double counting. And the reason why is because let's say we pick triangles over here and then we pick circles over here. And then there's just the 1 out of 8 chance we happen to pick this, right? All circles. Well, then that's double counting. Or if we pick all triangles, that's double counting because we could have picked these to begin with and then these are the randomized 3. So hopefully that makes sense. So essentially, if we pick, we can orient it 2 ways. And then we can pick if there's 2 triangles and a circle, or there's 2 circles and a triangle. And I mean 2 rows of. So we can pick if these are rows or columns. This is to represent if we're doing it with rows or columns. Let's say we pick columns, right? Like right here. Well, then there's 2 more choices, whether or not we have 2 columns of triangles and 1 column of circles, or 2 columns of circles and 1 column of triangles. And then the last thing we do is we just organize the 3. Right? And that's just going to be 3 possibilities. Because, for example, if we have a circle and then 2 triangles, we have to put it in one of the 3 spots, and the other triangles will just lay out however they want to. So this will give us 12. So actually 12 of them are being counted exactly twice. So we want to subtract these 12, and this will give us our actual answer of 84. We have this polygon ABCDEFGH consisting of rectangles and right triangles. And we are given some length. So and when we fold this into its triangular prism, we can tell this will also be 8. And this will also be 8. Right? Because when we fold it, we'll have it looking something along the lines of this. I think. Look like this, right? Where this is B, this is where A and C coincide. This is J. That's where J and D coincide, actually. This is where E and G coincide. That's where they meet. This is where F is. And then this is where H and I coincide, like right here. Right? Those are the points. And yeah, that's why all of these lengths will be 8. And GH is going to be 14. Therefore, this length here is going to be 6. This length here is also going to be 6 by symmetry, because these are both the same right triangles, and this is a rectangle in between. And then by 6, 8, 10 triangles, we get 10 and 10, right? We can use Pythagorean theorems, or if you know 3, 4, 5, we can figure that out. And now from here, it isn't too hard to figure out the volume of the prism, because what we do is we orient it so that the base is face down. And now it's just the area of the base times the height, and that'll give us the volume, right? So this is what it looks like, right? So the area of the base is going to be 6 times 8 over 2, which is going to give us 24, right? And then the height here is just going to be 8. All right. So we get 24 times 8. The volume is going to end up being 192. All right. Finally, we have number 25. A cricket randomly hops between 4 leaves on each turn, hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? Yeah, so what is the probability? Okay, so actually, what we can do for this question is we can define a recursive function. So basically, let P of X be the probability that the cricket has returned to where it started after exactly X hops, right? So essentially, P of 0, well, after 0 hops, it's on the leaf where it started. So that's just a 100% chance of happening. P of 1, well, there's a 0 chance of it happening because it'll have to be on one of the other 3 leaves. P of 2, well, no matter where it ends up afterwards, it's going to be on a different leaf. And from any one of those leaves, the probability of it going back to where it started is just 1 out of 3. And from here on, we can define a function like this, right? So P of n is just equal to, well, it's a 1 out of 3 chance, right? But only if it's not on the leaf on the previous turn. So 1 minus P of n minus 1, because P of n minus 1 is the probability that it is where it started after n minus 1 hops, and we don't want it to be on that leaf. So this is the recursive function we get. As you can see, if we keep on plugging in like 1/3 into here, then P of 3 is going to give us, well, 2/9. And then P of 4, if we plug it in again, is going to give us 7/27. And that will be our answer. All right. So yeah, this has been the 2022 AMC 8 problems 1 through 25. All right.